Question 21. When a force of 0.8 Newton is applied to a spring, the length of the spring is 90 millimeter. When a force of 1.3 Newton is applied to the same spring, its length is 115 millimeter. So del x is 115 minus 90 by 1000. I'm converting the millimeters to meters. This gives me 0.025 meters. The spring obeys Hooke's law, and we know the formula, which is k equal to F by x. What is the spring constant? We need to find out k of the spring. So k is equal to del F by del x. Del x we found here. So del F is 1.3 minus 0.8 by 0.025. This gives you 20 Newton per meter, which is answer D. Question 22. An experiment is carried out to investigate how it responds. An experiment is carried out using a metal wire to investigate how it responds to a varying tensile force. The cross-sectional area of the wire is constant. Which graph has a gradient that is equal to Young modulus? So Young modulus is stress divided by strain, and this is wrong, this is wrong. Yes, stress strain. This gradient is E. Young modulus. Answer is C. 23. For a wire, Hooke's law is obeyed for tension F and extension X. The Young modulus for the material of the wire is E. Which expression represents the elastic potential energy is EP stored in the wire? So EP is, we know from our theoretical knowledge, is half Fx. Answer should hence be C. Question 24. A plane polarized wave has amplitude A. The wave is incident normally on a polarizing filter. Normally, transmission axis of the filter is at angle theta. The plane of the 1 minute. Right, the plane of polarization of the incident wave, theta to the plane of polarization. What is the amplitude? We know this relationship, right? We have to use this again. We did use this in some question. Yes, in this question 19. We'll be using it again here. So I also did mention in the previous video that I had done a mistake in question 16. So I hope you watch the end of the previous video to watch the correct solution. I did a corrected solution of question 16 at the very end. Okay, what is the amplitude of the wave that emerges from the filter? So I equal to I0 cos square theta. So here A is directly proportional to root I, just from this equation here, right? So if we put root I to root I0 cos square theta and root over it, this would become amplitude equal to amplitude will become, let's say A1 amplitude will become A, which is the initial amplitude, cos theta. So this is your solution, A cos theta. Because we've done a root of this cos square, it became cos theta. That's why this are wrong. Question 25. An electromagnetic wave is traveling through a vacuum. What could be the wavelength and period of the electromagnetic wave? Okay, so we know that V equal to F lambda, and from this we know that frequency equal to V by lambda. Since these are electromagnetic waves, the speed is 3 into 10 to the power 8 meters per second. And for each of the options, let's first find out the frequency, which is 3 into 10 to the power 8 for question A, by 1.2 into 10 to the power minus 10. 1 minute. So yes, what I was doing is, so tera is 10 to the power 12 into 10 to the power 12. We're just converting it to meters. This gives a frequency of 3 to 10 to the power 8 by 20 to 10 to the power. This is 2.5 into 10 to the power 6. We also know that time period is 1 by frequency, so for it to come it has to be 1 by 2.5 into 10 to the power 6. This is not equal to this, and for that reason that is wrong. I will just erase this actually, and I will move on because I don't have much space. So I will do the same thing for part B. So the frequency is again 3 to 10 to the power 8 by wavelength is 1.2 10 to the power minus 12, which is just use your calculators, which is 2.5 into 10 to the power 20. So time period is 1 by 2.5. This is definitely not equal to this, so that is wrong. So A and B is wrong. Answer has to be something between C and D, but I hope the working is clear. This is exactly how you will have to do the working. For part C, the frequency is 3 into 10 to the power 8 by 1.2 into 10 squared into 10 to the power minus 12, which is into 10 squared, which is 2.5 into 10 to the power 18, and this is 1 by 2.5 into 10 to the power 18. So they've converted to nano. So what we will do is we will do into 10 to the power 9 for nano, and let's see, 1 by 2.5 into 10 to the power 18 into 10 to the power 9. Yes, this does give us 4 into 10 to the power minus 10 nanosecond. Hence answer is C. You can check for D as well, but it should be wrong. Question 26. Light of frequency this hertz is a vacuum. In a vacuum is incident normally on a diffraction grating that contains this many lines. So we know that D equal to 1 by n. So this value right here is n. So 1 by 4 into 10 to the power 5 is 1 by 4 into 10 to the power 5 is 2.5 into 10 to the power minus 6. For a diffraction grating, we know a formula which is d sine theta equal to n lambda, or from here theta is n lambda, sine inverse n lambda by d, n lambda by d. What is the angle between the adjacent second and third order? So n value, n equal to 2 and n equal to 3, and we have to find the difference in the angle. So do we know the lambda? No, we don't know the lambda. So lambda equal to V by F. V is 3 into 10 to the power 8. Frequency is given to us over here. So the answer is 3 into 10 to the power 8 by 6.7 into 10 to the power 14, which is 4.5 into 10 to the power minus 7. Now then we will put value of n equal to 2 ones and n equal to 3 ones, just like I've told here. Also replace the value of d and lambda, and let's find two values of theta. I will just do it in my calculator. Theta at n equal to 2 is sine inverse 2 into 4.5 into 10 to the power minus 7 by d is 2.5 into 10 to the power minus 6. The angle is 21.1. Theta at n equal to 3 is this time 32.68. So subtracting them, I should have the answer. 32.68 minus 21.1, which is 11.58, which is equivalent to 12 degrees. So answer should be A. So I'm actually erasing this thing from here. I hope you've seen the working. Okay. Question 27. The siren of a moving police car emits a sound wave with frequency this. Stationary observer hears sound of frequency this. So first thing is, it is moving towards, that's why the frequency increases. So this two are wrong. Answer will be amongst towards ones. Now we know a formula and we will use the formula. So f naught equal to the initial f into the v by the, what is the speed? So v, let's say that is v of the speed of sound, vs minus the v, and we need to find this v right here. So we will just do that. Or f0 is 494 and 440 v by 340 minus v, or 340 minus v equal to 440 divided 494, which is 0.89 v, or v equal to 340 divided 1.89. 1 minute. Something isn't right. Oh my god, what have I done? This is also V source. I'm so sorry, this is also V source. So I'll erase this line. And so 440 into 340 by 340 minus V. If it was going away, then it would have been plus. If it was going away, it would have been plus. That's just like plus minus. Or V is 340 minus 440 by 494 into 340. I am getting an answer of 37.2, which is 37 meters per second. So answer is B. 28. The diagram shows the shape at one instant in time of part of a stretched string as a wave travels along it from left to right. This is the direction. What are the directions of the velocities at the points given? So let me first draw the directions. Again, the theoretical knowledge here. This goes up, goes up, goes up, goes down, goes down, goes down. So now just use this diagram. So this you have to know. This diagram has to be known. So the answer, looking at the direction, should be C. D. So question 29. Which wave cannot be longitudinal? So longitudinal cannot be longitudinal. So okay, so answer is B. Polarized wave. Only transverse can be polarized. So a polarized wave is only transverse. What I wrote this means a polarized wave is only transverse, so cannot be longitudinal. So that should be the answer. Diffracted waves can be longitudinal. Reflected wave also, stationary wave also can be longitudinal. So answer is B. 30. Microwaves are emitted from two sources at points X and Y. The two waves meet at point Z. You can see that in the diagram, right? The diagram shows the paths of the two waves, right? And you see the path. Waves emitted from are coherent. Coherent means constant phase difference. So option with this theory will be the answer. But in the path lengths, not the path lengths, phase in the phase, right? There is a constant non-zero, not really. Non-zero, not really. So answer is B.